This is an introduction to the book, Project Economics for Mineral Process Engineers, Cost Estimation and Budgeting, by Tony Escorcio. To quote the book, "In the complex world of mineral processing, the difference between a successful project and a costly disappointment is often determined not solely by technical innovation, but by the discipline of financial planning, cost control, and economic analysis." All right, today we're diving into something truly massive. We're going to unpack the incredible economics behind building a modern mineral processing plant from scratch. And trust me, it's a financial undertaking on a scale that's pretty hard to wrap your head around. So, how in the world do you even get started on a project this big? I mean, how do you take a remote piece of land and transform it into a state-of-the-art facility that can process thousands of tons of rock every single day? Modern mineral processing plants require massive capital investment and demand comprehensive financial planning. The key to managing financial risk is understanding the scale of the project. These complex projects operate on a billion-dollar economic scale. Yep, it's a financial blueprint, a meticulously detailed map of every single dollar you're going to need to bring one of these giants to life. Because, let's be honest, without the funding, even the most brilliant engineering is just a dream on paper. Initiating massive billion-dollar projects requires a rigorous approach. Transforming remote land into a processing facility is challenging, so successful projects start with detailed scoping and feasibility studies, which require comprehensive planning. And the numbers, they're just staggering. A big project can easily soar into the billions. This number right here, $2.5 billion. That's a totally realistic price tag for a world-class plant. That kind of money puts immense pressure on everyone involved, right from day one. A detailed financial blueprint is crucial for project success. Comprehensive planning outlines the required capital expenditure. A robust plan manages the financial lifeblood of the operation. Initial planning ensures the project's long-term financial viability. A detailed financial map tracks every dollar needed. Funding transforms brilliant engineering designs into reality. A comprehensive blueprint details the required capital expenditure. No billion-dollar project can succeed without proper funding. Billion-dollar mineral projects involve truly staggering expenditures. High capital costs necessitate rigorous financial planning from day one. A world-class processing plant can easily cost $2.5 billion. This massive investment creates immense financial pressure. Okay, so let's get into the nitty-gritty. The whole cost structure is really broken down into two main pillars. The first one, and it's the big one, is that huge one-time investment you have to pour in before you make a single dollar back. This is what's known as capital expenditure, or CapEx for short. Capital expenditure basically covers everything, and I mean everything, it takes to build the entire operation from the ground up. We're talking from the very first geological survey, all the way to the final coat of paint on the handrails. You know, a really significant chunk of capital expenditure is spent before any real construction even starts. This is all the work to prove the ore is actually there, to get all the right permits, and to literally move mountains of earth. These are what you call sunk costs. If the project gets cancelled at this stage, that money is just gone. It makes this early phase one of the riskiest parts of the whole venture. Then, of course, you have the heart of the project, the processing equipment itself. We're talking about giant crushers that can chew through solid rock, enormous grinding mills, super sophisticated flotation cells. This kind of custom-built, highly specialized machinery is almost always the single largest piece of the entire capital expenditure pie. So you've done it. You've spent the billions, the plant is built. Now you have to actually run it. And this brings us to the second major cost pillar: the daily, monthly, yearly expenses of just keeping the lights on and the wheels turning. This is your operating expenditure, or OPEX. Now, this points out a really key difference within OPEX. It's not just one big number. It's split into two totally different kinds of costs. Variable costs, which go up and down depending on how hard you're running, and fixed costs, which are pretty much always there. Think of variable costs as the direct cost of doing business. The more ore you process, the more electricity you use, the more steel balls you need for the mills, the more chemicals you buy. Mastering these costs is absolutely crucial, because they directly affect how profitable every single ton of product you ship out the door is. Fixed costs, on the other hand, are the complete opposite. These are the bills you have to pay just to exist. Things like salaries for your permanent staff, insurance, software licenses, security. These costs don't change whether you're running at 100% capacity or you're temporarily shut down. This constant financial drain is exactly why a plant's uptime and efficiency are so critical. Okay, so we've got these two huge buckets of cost, CapEx and OPEX. But how do you go from these big, abstract ideas to a real, functional budget? You know, one that you can actually take to the bank and get funding for. How do you build that confidence in the numbers? Well, it's a process of refinement. Think of it like a funnel that gets narrower and more precise as you go. You start out with really broad, order-of-magnitude guesses based on similar projects from the past. Then, as you move through all the studies and detailed engineering, you start replacing those assumptions with hard data, until, finally, you're working with actual quotes from vendors. The budget just gets more and more accurate with every single step. And, you know, within that process, there are really two main ways of thinking. Top-down is when leadership sets a total budget number and tells the team, make it work. Bottom-up is when you meticulously add up the cost of every single bolt, wire, and hour of work to get your total. In reality, any successful project uses a mix of both. You need to stay aligned with the big strategy, while also being relentlessly accurate on the details. So, let's bring this all home. Why does this intense, almost obsessive focus on numbers matter so much? Why is this kind of financial discipline the absolute bedrock of these giant projects? Well, as the source material puts it so well, this isn't just about accounting. Having that rigorous economic planning is what makes the difference between a successful, sustainable operation and a very, very costly failure. And that kind of leaves us with a final thought to chew on. After all this planning, after all the detailed estimates and quotes, is the budget for a project like this ever really set in stone? Or is it more of a living document that has to constantly adapt to a world of volatile prices, unexpected challenges, and new technology? That right there, that's the real tension at the heart of building these industrial giants.